Hello, I'm Ditch and welcome to my channel. So today's topic is a little different. We're not going to be discussing boring motorbikes or fuel injection projects. No, today we are delving into the exciting world of data storage. Now, this is my computer. I built it about a year and a half ago using mostly second-hand parts. It cost me about £600 altogether, including all the peripherals, not that screen. Normally it doesn't live here. It has a 4K 60Hz screen. Basic specs are Asus ROG Strix Z690 motherboard. Processor is 12th generation Intel 12600K. It's got 32 gig of Corsair Dominator Platinum DDR4 RAM. It has a GeForce RTX 2080 graphics card, and for storage I have two M.2 drives, one which is a 1/4 terabyte that I use for my OS, and another one that's 1 terabyte that I use for my data storage. Now, it's not a high-spec machine, it's fairly modest spec, but it gets me by. Bearing in mind, I'm not all that interested in playing games. Most of what I do is video editing, and that unfortunately needs a lot of storage. If you've ever edited a video, you probably know this already. I use DaVinci Resolve, and I use the free version, and this machine isn't the highest spec machine out there. So there are always compromises, and one of those compromises usually involves needing more space. So right now my 1 terabyte data storage space is completely full, and I have a box of memory cards with raw unedited video that are just waiting to be edited, and I can't do anything with that stuff right now. So the easiest solution is put in another hard drive. Now, this board's got 4 M.2 slots, only 2 of which are populated. So in theory, I could just buy an M.2 storage drive. I kind of decided to myself, I think 8 terabytes is about where I want to be for storage. So I went shopping, as you do, and I discovered that 8 terabyte M.2 drives cost about £1,000, which I was a bit surprised by. And something else to consider is that buying one 8 terabyte drive means I have 8 terabytes of insecure storage without a backup. So in theory, to create secure storage, I would need to buy 2 of those drives, which would be £2,000, which is definitely not something I plan on doing. So next I had a look at regular SSD drives, and I even made a few notes looking at the prices of these things. You know, your bog standard 8 terabyte SSDs are about £600 each, so now I'd be looking at £1,200. Of course, I could go with a smaller drive, with a 4 terabyte drive, and just use 3 drives, 2 for data and 1 for parity to secure the other 2, and that would reduce the price a little bit. But even 4 terabyte drives are £300 each, so you'd still be looking at £900. Next, I just thought, well, what about hard drives? Just regular spinning platter hard drives. If I could get 4 terabyte drives, they'd only cost about £150 each. So I'd be looking at about £450 worth of storage. But the problem with those drives is they're almost always, those cheaper drives are almost always SMR drives. And if you're not familiar with the whole SMR versus CMR, SMR stands for shingled magnetic recording, and the way that works is, in order to get more data into the same size platter in the hard drive, they squish the tracks much closer together, and they actually start to overlap each other like shingles on a roof. That's why it's called SMR. And what this means is, if you're writing to that track, you can't write to it on its own. You have to write to its neighbors at the same time, because they're squished on top of each other. So when you're writing to a track and its neighbors already have data on, you have to also read that data and rewrite that data. So it ends up slowing the whole system down and can cause some serious issues when you're trying to do what I'm trying to do, which is build an array of storage for long-term archives with some kind of security. So in that situation, even if you're going with hard drives, you end up having to go with the more expensive sort of £200 each hard drives. So you'd be looking at £600 there for 3 4-terabyte drives. So then I started looking at secondhand stuff and actually bought a drive. I found a guy selling a 4-terabyte hard drive. I bought an external enclosure for it. It was on eBay. He had some pictures on the listing showing the health of the drive and the fact that it was still in good condition. And it may have been in good condition, but by the time it got to me, it was dead, unfortunately. And I think that's purely because eBay sellers may know what drives look like and how they work, but they really don't know how to package them for shipping. It was in some bubble wrap in a box, but clearly not protected enough because it arrived dead on arrival. So I had to return that one and went back to the drawing board. But I wasn't quite ready to give up on the whole idea of buying used hard drives. And I found a couple of places online that sell them, that are reputable companies and obviously know how to ship them because they offer warranties. One place was called Tech Buyer. These guys seem to specialize in server equipment and recycling or repurposing server equipment. And they have a load of hard drives on their website. So I went and had a look, and I found some for £30 each for 4-terabyte drives, including that with free shipping. So I bought 3 of them. And this is what they look like. 4-terabyte drives, extremely well packaged, and they have a 3-year warranty. Now, there is a catch with these because they're not SATA drives. And I knew this when I bought them, but these are SAS drives. These are the types of drives you find in a server and in an enterprise system. So they won't just plug into your normal SATA ports on your computer. But I also happen to know that there are ways you can get around that. I think these are quite cheap because I think they probably recycle quite a lot of server equipment, and some servers will have a bunch of these, maybe 20 of these 4-terabyte drives in them. But the vast majority of people don't want these drives because they're not just plug and play in your average desktop computer. So I think that's why these are fairly inexpensive. But the price per terabyte for drives with a warranty, I don't think you can really beat that. One thing about these as well, because they're enterprise drives, they're very high quality, very robust. They're designed to run for a decade continuously and not give any problems. And because of that, though, you might find they have a few working hours on them. I checked these, and they've been in a machine somewhere for 6 years. But I like to think of it like a car that's been on the motorway for most of its life. It might have slightly higher mileage, but the clutch is going to still be okay, and the gearbox hasn't worn out, and the brakes are still good, compared to a consumer drive that's been switched on and off all the time and not left running in an air-conditioned enclosure. You know, that's a bit like a car that's been driven to the shops and back with a worn-out clutch, a car that's been driving under its operating temperature for most of its life. So I think these are probably going to be okay, and they offer a warranty anyway. So, but you do need some extra hardware if you want to use these in your bog standard computer, because your consumer grade motherboards, they come with SATA controllers on board and SATA connectors. And as I said, these are SAS drives. But it is possible. It is possible. What you need is you need a tool. You need a card called a host bus adapter, or an HBA, and it plugs into your computer and it can communicate with a SAS drive. And most of them can also communicate with SATA drives. So you can mix and match, but you need to check that first before you buy anything. But a lot of them you can mix and match SAS drives and SATA drives. Whereas with your standard SATA controller on your computer motherboard, it's limited to SATA drives only. Now, I bought one, and it looks like that. This one came off eBay. It was about £32 second-hand, because a lot of these are only available second-hand for reasonable prices. They're very expensive when they're new, because, as I say, this is enterprise hardware that goes into servers and things. But when they decommission servers, all that hardware's got to go somewhere, and that's one good source for these. So there are quite a lot of these floating around on eBay and second-hand, marketplaces. But there are a few things that you need to be aware of before you buy one of these. A few considerations. One of the main ones, I think, is the firmware, because these cards, usually their firmware includes RAID, which, if you're not aware what RAID is, it's a tool for managing disk space, arrays of disks, creating pools of data across multiple disks and arranging for backups within an array of disks and things like that to protect your data. These cards often have that software built in. And that's not what you want if you want to put this into your desktop computer, your normal consumer grade computer, because it hides your drives from Windows. It'll only allow Windows to communicate directly through it. You won't see your drives come up in, my computer or even in your disk manager. Everything has to be done through here, and the card's firmware has to be configured to create the pool of data space and to manage it, and it all has to be done through some kind of utility. And some of it often involves you getting into the nitty-gritty of the programming of the thing. And for a lot of people like me, that's just it's not something I really want to do. So what you want is, instead of getting one of these with its own original firmware on, you want one that's been flashed into what they call IT mode, which is more like a basic communication tool. It just communicates with the drives and relays that straight back to Windows, and your drives come up in Windows just like they normally would. What's that called again? It's called initiated target mode. Yeah, don't ask me what that means. And IR stands for integrated RAID mode. So you really don't want one in IR mode. You probably want one in IT mode. Now, a lot of people take these and flash them with IT mode firmware before they sell them, which is really handy. And when you see a listing like that, you know you're going to be getting a card you can use. Some people, unfortunately, don't really know the difference, so they don't put that information on the listing. This one, this particular card, doesn't actually have an IR mode. It only comes in IT mode, because it's intended only to ever just simply connect your motherboard to the drives and let your operating system handle everything, which is quite handy. I'll put something in the description about what the specific model is if you're interested. But it is probably easier to do things that way. You can also buy a card that's in IR mode and flash it yourself. But that, once again, you're getting into the programming side of things again. You need to use a special utility for it. If you're comfortable with command line, you might be okay with that, but I'm not. And any tiny mistake will brick it completely. So, I've been leaning quite heavily on Google's AI for this project, and it told me that your usual consumer grade computer hardware is not the best stuff to be flashing these cards, and the people who do this usually have more sort of enterprise grade equipment to do the flashing with, so it's not advisable. Anyway, your mileage may vary. It's your money, do what you want with it, but I would recommend trying to find a card that is already in IT mode. Now, this is actually the second card I bought, because the first one, the description said non-RAID, but it turned out it was a RAID card and it was still in IR mode. And me and my new AI friend went round and round a few times trying to work out why nothing was working. And eventually that's what we figured out. It took a while to get there though. And to be honest, if the AI had said, look at the drivers and send me a screenshot, we would have solved that problem very quickly. But anyway, it went back and I bought this one. So yeah, a few other things to note about these cards. You get sort of two main types, which is internal and external. This one is an external card. It's got the ports on this side of the bracket. Internal ones have them on this side. So obviously for cables to go to drives inside your computer case. The internal ones have these little black plastic sockets. SFF 8643 they're called. The external ones have these metal sockets, and there are two main types. This square type one, there's actually two sockets there, but the square type ones, that's SFF 8644, and then there's a rectangular one that's a bit bigger, which is SFF 8088. As far as external ones concerned, you just have to get the right cable to match the right socket. This is a slightly smaller, more compact socket. This is the, as I said, the 8644. And I think the cables that attach to these are a bit more pliable, less rigid and stiff, which is why I went with this one. But it's not that much of a difference. You just need to be aware that there are the different sockets and make sure you get the correct cables to match. Something else to consider is the brackets. That one has a low profile bracket. That won't fit in a standard ATX case. Sometimes it's easy to find a replacement, a full-size replacement bracket. Other times, other cards, it's impossible to find. And many of them, like this one, the tabs are folded over. It doesn't have screws on the face. The screws go through the board. So it's not easy to just take a standard bracket or a blank one and just modify it to fit. So you kind of need to have the right sort of bracket for it. And if it doesn't come with this full-sized one, I would first check, see if you can get one before I buy it, before I buy the card. I was fortunate that I bought a full-size bracket for the previous card I had, the one that got returned, but it turns out it's an okay fit for this one too. So I do have a full-size bracket for that. Yeah, where it goes in your computer, it fits in a PCI slot, and it needs an 8 times sized slot. So another thing to be aware of is to make sure you have a free slot for it to go in. It won't fit in a standard PCIe 4 times slot, the really short one. It needs an 8 times or bigger. Now I have a spare 16 times slot at the bottom of the motherboard that this will go into. And it doesn't matter if it's running at 16 times, if it's populated with all the lanes for 16 times, as long as it can fit in the slot. That's the thing that matters, because your motherboard will and the card will communicate and adapt to which lanes are available for use. One thing to be aware of though, if you do have some kind of PCIe sharing inside your motherboard, like with this one, the bottom PCIe slot is shares a bus with the with 2 of the M.2 drive slots. And if you put your M.2 drives in those slots and plug this card into the PCIe slot, it may create a conflict. So what I did was I moved my M.2 drive into one of the other slots that doesn't share a bus with the PCIe slot at the bottom of the board. So something else to be consider there. Another issue is these things tend to run quite hot, because they're designed to be in a server with a fan blowing over them, and they don't generally have their own active cooling. So you've got a heat sink, but you don't actually have a fan attached to it. So you have to make some kind of provision to cool these things with some kind of fan when you mount them in your computer. So that's another thing to consider. Is there space in there for a fan to blow directly onto this heat sink? And then another thing is, some of the older generation of these have limitations on the capacity of the size of drives that they can manage. You know, some of them might only be able to go up to 2 terabyte drives. And this is something you need to check before you buy. Once again, Google AI is very handy for that thing. You can just take a picture of the listing, a screenshot, upload it, and it'll tell you exactly what you're looking at and what you can and can't do with it. Yeah, also on the subject, this is a single controller. There's one SAS controller on this card. You'll see it has 2 ports because one SAS controller can control 8 hard drives via 2 ports, so 4 for each port. The first one I bought actually had dual SAS controllers on it, so it had 4 ports to control a total of 16 hard drives, which is a lot. Personally, I didn't choose it for that. I chose it purely because it was only £17, so it was very cheap. Personally, I would have preferred not to have the dual controller because I think twice as many controllers means twice as much heat that you need to dissipate, and I can't imagine needing to put 16 drives anywhere. I think 8 is plenty for my future needs, to be honest. So something else to consider. But yeah, pretty basic. That's the card. And then into that, we need to be able to plug some cables. Now, this is an external card because I'm planning to put my hard drives in an external enclosure that I'll be 3D printing myself, purely because that's the kind of person I am. I like to build stuff. So I need a cable to go from this to the hard drives. Now, you can buy a sort of breakout cable that plugs into there with 4 connectors on the other end to plug into 4 hard drives. But I noticed that they were a bit hard to find in the UK, particularly for this SF 8644 connector. There were some around for the 8088 connector, but not for this 8644 connector. So I chose to go a slightly different route. I also don't like the idea of having the cable routing from inside the drive enclosure and out and permanently attached to it. I wanted to be able to unplug the cable from both the card at the computer end and the drive box at the hard drive's end. So I came up with a slightly different way of doing it. I bought this cable here. Now this has the SF8644 connectors on both ends. So this obviously can't connect to any hard drives at all. But what I also got is this pass-through card. And what that is, it's got the 8644 connector on one side and an internal connector on the other side. And you can see this one's actually got 4 ports. So it would have been perfect to go with that dual controller that I had previously. So I don't need all 4 ports. But as it turns out, this is 2 separate pass-throughs joined together on a steel plate. In fact, we can disassemble this right now. So you actually have these 2 separate twin port pass-throughs, of which I only need 1. But the idea here then, that will stick out of my enclosure and connect via this 8644 cable to the HBA card, and the other side I now have an internal SAS connector, well, a pair of them, and that will connect to this cable. Now, this is an internal SAS breakout cable. So it has the internal, the 8643 connector on this end, which connects to that. And on the other side, you have your 4 drive connectors. Now, these look very similar to a SATA drive connector, but they're not. They are SAS connectors. And on the back of each of these connectors is a standard SATA power socket. So that's how you power the drives, is by plugging in a SATA connector in the back of that SATA power connector. So this will then be inside my enclosure, providing my connection to these drives. So I think that's quite an elegant solution. One thing about this though is it's got no holes in it. I noticed the way this bracket attached, it literally just squished the circuit board with a big plastic cover. That's how it held it in place, which is a bit crude. But the design for the enclosure will have a shelf for it to sit on and a clamp to clamp it in place. So that's sorted. We've got our cable sorted. Next thing we've got to look at is power. So I've got this. This is an SFX power supply, so quite small compared to the ATX form factor. It is 250 watts, which is plenty for some hard drives. I've already modified this slightly. I've cut a 12 volt connector for a fan connector because I need a fan to keep these hard drives cool. And I've cut into the main motherboard connector for a power switch and an LED light that's going to be on the power switch. So I've done that already. It has one rail with two SATA power plugs, so that'll power two of the drives. I've got a SATA or a Molex to SATA connector adapter for one of the other rails because it has one rail with two Molex connectors. Now at some point I'm going to cut that Molex plugs off and just solder those wires together. But for now it's good enough for testing. It's just not recommended to keep it like that because, you know, the saying Molex to SATA lose your data. That's what they say. They're terribly unreliable, these Molex to SATA adapters. So I'll cut it off and solder it, but in the meantime I've got a power supply chosen because of its compact size and because it's a good reliable type of power supply. On top of that, I've got a nice little 60mm fan on a little 3D printed bracket that we can fit inside my computer. That will be cooling down our HBA card when it's in there because it does need some active cooling. Now, I have a 3D printer which makes my life a lot easier, but this will only fit that particular case. But it'll work, I think. Then I've also got a standard 120mm fan, 12 volt, simple 2-cable fan, and this is going to be in the enclosure and cooling down these hard drives. So a 120mm fan can cool 4 hard drives. Up to my estimation, if you consider the width of a hard drive, you could stack 4 together and cool all 4 with one fan. So I only need one for now. If I decide more, I need it in the future, I can always get more fans. So also in this box, power switch. This is a standard 12mm push button latching power switch. It has to be a latching switch. This will be used to switch on the power supply. It has an integrated LED as well. I've already stuck a plug on the end of that to fit onto that onto the wiring harness of that power supply. It came with 2, but I don't need 2. And then one other thing, as I said, I bought a standard bracket previously, a full height bracket for the other card that I had, but fortunately it does fit this card. The whole spacing is exactly the same. The only difference is it's got a much wider slot because it had 4 ports, which isn't a problem for this one because it doesn't matter if there's a bit of a gap, it's just going to create better airflow. So what I'm going to do now, I'm going to put this lot back in the box because I want to show you the actual enclosure that I've 3D printed. So first of all, I wanted to make it fully modular and fully scalable. So I decided to go with individual drive bays. I came up with a very, very simple design for a plastic bay like that. Nothing spectacular. These are printed in ASA, so they should have no issues with the temperature of the hard drives. All the mounting points are heat sets, these little brass heat sets, which I love using. And I've put a bit of a fuzzy skin texture on it just to see what happens. But basically, that's just a tray. Onto that we fit our hard drive, which will screw in like that. Should give us plenty of space at the back here for our connectors and cables. The sides are open because we'll be slotting in some 3D printed mesh panels like that. And all that holds these in place will be the next drive bay sitting on top of it. Pretty simple stuff. And then once we've stacked 4 of these together, our fan will fit to the front of that. So very simple concept. I've already printed all of these parts. So we have another 3 of those simple trays. A whole bunch of these yellow, bright yellow hexagon shaped panels. This is our fan mounting. It's going to go on the front. I love how lightweight these ASA prints are. Simple, also sticking with the same honeycomb theme. And then on top of all of it, there's a top panel, also with our honeycomb theme. This is partly for the aesthetics, but also partly because it's just going to give us really nice ventilation in there, make sure we get good airflow. So that will fit onto the top drive bay and screw in place, and also hold the mesh panels in. That's the wrong way around. And hold the top row of mesh panels in place. But the idea being that if you ever want to add more, you can remove that and just 3D print some more of these bays. This will just fit on top with some more of these panels and bolt together. So very simple, very modular, completely scalable. And all of that's going to sit on a base, and the base will house your power supply, pass-through board, cable connectors, and power switch, and your connections for your fan and all of that. So I printed that out of ASA, and it just didn't work. I mean, I made it quite, there's not a lot of plastic in there because I've put ventilation there to draw cool air into the power supply vents underneath. There's a great big hole in the back where the power supply lives, but the problem is it just bent. It didn't pull away from the build plate, it bent the build plate away from the magnet. So that just didn't work in ASA. So then I had the idea, what about printing it like that? And then I can make some panels that go in there. And that was better, but not quite right. The back, I got quite a lot of warping around here. When the bridge happened, it was all out of alignment. So that might have been usable, might not, I don't know. But I wasn't happy with that. So in the end, I printed that out of PETG instead of ASA. That obviously didn't warp at all, because PETG doesn't really warp like ASA does. So that was easier. For now, I'll use that. I don't really like printing in PETG, it's too shiny. But for now, I'm going to use that, and we'll see how that goes. I might reprint it again. I did think I might break it down into panels that you can print flat, because that's one of the reasons I made these the shape I made them. With ASA, as soon as you've got big vertical walls, it wants to pull the whole print. So instead I left them as just pillars with panels that you slot in, and these panels are just printed face down on the build plate. And they fit together quite well. they mean I can do a different color. They look quite good, and everything's reasonably straight. These did bend a tiny bit. They bent that way, but when I screw it all together, that should straighten everything out. So yeah, so I've printed all the parts, all the 3D printed parts. You can see the back of that. There are some features over here. The purpose of that is to mount that pass-through card, because as I said, it doesn't have its own screw holes. So the plan is for that to just go in there and sit on a shelf. There is a notch in the board, so I've left a little spigot that locks it in place, and all we need to do is put a 3D printed clamp over it, and we have it protruding out the side, because it needs to be quite stable, because you're going to be sticking a plug in, so it mustn't be able to slide, but that way it's locked in place on that spigot really well. All it needs is a simple 3D printed clamp, and that'll hold it in place really well, and it's not in the way of anything. And with the power switch directly above it, it'll look quite professional, I think. Look like it should look. So that's what that feature is over there. I've done the same thing here. It's just easier to see with that one. So yeah, I think the next thing to do is to put this all together, and I'll show you how all of it works. Right, so I think the first thing to do is to sort out this power supply module. So what we need for that is the power supply and the switch. Just move a few things out of the way. So I'll do that first. And the power supply fits in there like that, all the way in the end, and then the cooling slots line up with the slots on the power supply well enough to ensure we get pretty good airflow through there. I've already got a bunch of screws, bearing in mind some of these are metric and some of them are imperial. In fact, actually, before we install that, I think we should get the pass-through card in, because it's going to be easier to get to the screws without the power supply in the way. So that just sits there in its little position. It's locked in place and can't move at all. And then we have a simple bracket with a couple of cap screws into some heat set inserts to hold it in place. And now that that's locked in place, you can see the connector protruding, and it's not going anywhere. I'll be able to plug into that without that moving. While we're here, let's get the switch in as well. Now, do we use the blue one or do we use the red one? Let's go with red. As I said, it's a 12mm switch. I think, to be honest, 12mm is a bit small. It's a little difficult to press in. I would have probably gone with a 19 or bigger if I was doing it all again. I might, in fact, buy a 19mm switch at some point and just enlarge the hole. Could use a step drill to just drill the hole out a bit for a bigger switch. Or be a Philistine and tighten that up with a pair of pliers. So that's our switch. As I said before, I've already put a plug on the end of that. So that's easier to do without the power supply in there. Now we can install the power supply. So that's the power supply installed. Looks reasonably tidy. These feet are separate feet that are glued on, and they've got little TPU inserts in them in an attempt to keep it from sliding around too much. That feels okay. Now, when it comes to the wiring, the power switch and the fan, they both need 12 volts, which is where the yellow and black wires come in, because they are 12 volts. I think the red wires are 5 volts. And then from the main motherboard connector, we've spliced into one of the black wires and the green wire. And that's what gives us our power on. It's what turns the power supply on in the first place. So that's our fan connector there, and then that's our power switch connector there, which connects, as I say, to the red and black, as well as a yellow and black to provide 12 volts. Then we've got our 2 rails with our SATA and Molex, and the rest of this wiring is completely unneeded. And at some point I might just cut all of that off. So let's try and get this all down there, tucked away as well as we can. And then while we're in here, we also want to connect this breakout cable. We'll connect it to the top port, I think, because we have 2 ports. We need to make sure we use the right one and we know which one to connect our cable in. So I'm going to use the top port, I think, and it's upside down. But it does clip in quite satisfyingly. I'll try and go around that in a coil inside there, I think. And now I think we're ready to install the hard drive. Now the question is, do we put the tray on first and then attach the hard drive, or do we attach the hard drive to the tray first? Let's try it the first way. Now, it's got to go the correct way around. All of this wiring needs to go through the tray, including our 4 breakout cables. I like doing it this way, I think, because I can see what the wiring's doing in there. So let's do that. 6 M3 cap screws per tray. Actually quite a lot of wiring to tuck away inside here. So our first hard drive goes in. Should be enough space, I think. We'll try and keep the wiring all the way on this side to make space for the connector on the other side. It's pretty simple. Just a simple vertical panel with a couple of holes in that line up with the mounting holes. Incidentally, I had to print this slightly overscale because of the shrinkage of the ASA. It ended up 0.3% bigger to get everything to line up. So it's modeled on the size, but then I had to scale it to 100.3% to get it all to fit correctly. Now, I do want to run the cable for this fan while we have all of this open. The fan's going to sit on the front like that with this shroud in front of it. So I think I'm going to do that now. Just mount it at the bottom, and that way I can get the cable in place. We can get it straight later. For now, I'm just more concerned about getting the cable attached. And then we need to connect our first of our SAS drive connectors and one of our SATA power connectors. Can only go the right way around. This is where we find out how much, if we've left enough clearance at the back for all of these cables to sit in. Now that we've done that, we can install our little mesh panels. They are quite a tight fit, but I didn't want them to be vibrating and rattling around. Then as soon as that's done, we can get the next tray. And hopefully it all holds everything together. That needs to tuck down there. Yeah, did I mention there's quite a lot to fit in that space? That's better. Yeah, I wanted that fan wire to live inside this area there. It's already getting quite heavy. So far no cracking noises, which is always good. Now you need another hard drive. I've labeled these drives, numbered them 1, 2, and 3. And I'm going to connect them into connectors 1, 2, and 3. Purely because it means that if I ever take them out and put them back, I know where they went. And I don't know if they need to be in exactly the same space to retain the drive letter and description in our disk manager, but I decided to do it that way just to be on the safe side. All right, so that's drive number 2. So we need SAS connector number 2 and SATA power connector number 2. It's already looking pretty good, I think. I do love 3D printing for this kind of stuff. You really can design anything and build it yourself. I never print Baby Yoda or Grogu or whatever you want to call him. Hardly ever print benchies, but give me a functional project and I'm right there with the 3D printing. As we go up, we've got less and less wiring to worry about. So now we can mount our last drive. So port number 3, and this is where we are going to need to use our Molex to SATA adapter, which I would have preferred not to use, but this is what we've got to do. I wonder if I can tuck some of that wiring down there. Some of it, but not much of it. Well, fortunately there's another bay coming with some space in it. So far everything fits really well. Really like the black and yellow. So that's our top bay, which is not populated at the moment. But obviously at any point we can add another drive there too. Right, so that's looking okay. And now we can actually put the other 2 screws in for the fan mounting, which is nice that even once you've stacked them together, the screw holes still line up well enough to get the screws in. Don't need to tighten it aggressively. Looks okay, that. So now we'll get the last of our mesh panels in. And then the final piece, let's see, there's plenty of space for that wiring to sit in there. The final piece is the lid. I think this is as simple as I can design something. Minimum number of parts, easy to print as possible. But I did add the fuzzy skin texture to the ASA parts to see if it would look good. And I think it does hide the layer lines quite well, actually. Makes for quite a nice looking textured finish. And that's the box complete. I think that looks pretty good. It's got plenty of ventilation, the wiring's all nice and tidy. So I think the next thing to do is plug it in. Make sure everything spins up. I'll go and get a cable. So let's get this guy plugged in and hit the power button. Now, I can hear the fan powered up, but what I can't hear is anything from the hard drives. And that is actually to be expected because these drives won't power on unless they get a handshake signal from the controller. And we haven't even connected that yet. So we'll switch this off and we'll get into the computer and install that HBA card. So the first thing we're going to want to do is swap out this low profile bracket for the standard bracket. We'll keep the bracket in case we ever need it later. Now you might be tempted to just 3D print a new bracket, but these cards want a good grounding. And they even have these little metal fingers that are meant to contact the bracket to ensure that you get a good grounding. So I wouldn't recommend 3D printing one, to be honest. As I mentioned, this is for a different card, but even though the hole is bigger, it'll still work. But I did actually have to file a little bit out of this to get it all to fit properly. Even with the card it was meant to fit, it didn't fit perfectly. So now we have the correct standard bracket. We can get this in our computer. But before we do that, I'm going to mount this fan. Might not be able to see so well what I'm doing, but the fan actually sits in here. I added this connector that just plugs into one of the case fan headers on the motherboard. I highly recommend you buy a crimping set to add these sorts of connectors yourself. If you ever do this kind of stuff, it just makes things a lot easier. I can plug that in. Even though we're only using 2 terminals on that connector, I put 2 dummy terminals in there purely because by doing that it gets a better grip. It's less likely to come out. Now we can install our card. I'll show you what that looks like. So you can see our card here installed in the lower PCIe slot. Not a lot of space, and there's our little fan bracket. 3D printed bracket. It's mounted from underneath with a couple of screws and connects directly to a header down there, little case fan header. So now I think we can move our camera back and get this whole thing plugged in. Right, now according to AI we should first power this box up and then power up our computer with the box connected. Now I found that didn't work very well. If you do it that way around, it still didn't power these drives up. But what did work is to power up the computer and then connect this and then power this box up. That forced the handshake between the drives and the HBA card. So we'll do it that way. So we've got our C drive and we've got our standard data drive. When we power this on, after we've plugged it in of course, hopefully our other drives turn up in a disk manager. You can hear the hard drives actually waking up there. We have our 2 drives there. And there we go. All of our drives have come to life. They've turned up in our disk manager and everything's initialized and working. And there's our 3 4 terabyte drives. If we go into my computer, they've turned up here as well. You probably can't see that from that angle, but they are in my computer. Now, I've already done this. So I took this apart because I wasn't happy with the screws that I'd used to install these drives. So I was going to take it apart anyway, so I thought I'll go through the process on video. But I've already done this before. And that's how I knew it works better if you plug it all in and then switch this box on with the power connected and the computer booted up. It needs that handshake because this is a hot swappable system. You can plug it in and switch it on anytime with your computer on. Wouldn't recommend unplugging it because you might corrupt data somewhere. There is, as far as I know, no way of removing it until you power down your computer. But once you've done that, you can switch it off. As far as managing the volumes on here, I'm using SnapRAID because I think it's the most convenient. So I've got 3 disks, 3 drives, 2 will be used for storing data and 1 will be a parity drive, and the parity drive then secures the other 2, and you can have as many drives as you want. You only need 1 parity drive to do the calculations to protect all of your data in case of a 1 drive loss. And with SnapRAID, it doesn't do any calculations while you're moving things around, storing data right into the disks. It'll only do it when you tell it to, do a synchronization, and then it'll check the data on all of your drives, whatever's new, whatever's been added or deleted, calculate all the parity mathematics, and then store the parity information on your designated parity drive. And as long as that drive is as big as or bigger than whichever other drives you're using, you only need 1 extra drive to give yourself that data security. And make sure that if one of your hard drives dies, you still can retain all and recover all of your data. So very easy to do with SnapRAID. And when you're not doing a sync, you just use your drives like normal hard drives, like you normally would, put what you want on them, use them how you want. So I've got 1 dedicated for work stuff, 1 dedicated for personal stuff, and then 1 for a parity drive. If I had another 4 terabytes, then I'd have immediately another 4 terabytes of space. Obviously, because it's modular, I can add more on top of that. I could go up to 8 drives. I'd need another cable and another set of internal cables and another set of drive trays. But this would just end up twice as high, but have 8 drives in it. So as far as speeds go, if I copy to these drives, I get about 200 megabytes per second, which is not bad at all. When it does a sync, it does the sync at about 400 megabytes per second. These are spinning platter hard drives. They're not as fast as SSDs, but that's fairly good, I think, you know. And on the whole, I'm very happy with the project. I will say, though, once again, I did lean quite heavily on AI for this, on the Google AI, because it's extremely handy for stuff like this. If things aren't working, you can upload screenshots to it and say, this is what I'm looking at, why is this not doing what it's meant to? Before you buy stuff, you can take screenshots of it, upload it, and it can say, yes, that'll work, or no, that won't. It knows what all the different cables are. It can source them for the best prices if you want. We went through, I don't know, 20 or 30 different eBay listings for these HBA cards before we settled on that one in the end. And each time it could tell you what generation the card was, what sort of speeds it'll run, whether it has any limitations on the size of drives it can connect to, that kind of thing. So useful information. I found it very, very handy. And in the end, this has been a pretty rewarding project. Now, as far as cost, everything here, including the card and the cables, the whole lot, came to less than £200. which is pretty good, I think, for 12 terabytes of space, with 8 terabytes usable and 4 terabytes for parity. So enterprise grade, server gear, robust, long lifespan stuff with full parity protection and totally expandable, all for less than £200. And I'm including my filament in that price as well. And every nut, bolt, fan, screw, everything that I've bought, all comes to less than £200. So I'd say a pretty good result, really. I think I've solved my storage issues. And going forward, I can expand it even further. So yeah, any questions or comments, feel free to leave a comment. Thank you very much for watching, and I'll see you again soon.